Hey, Harsh here. Today we are going to talk about webhooks and post notifications. Before we talk about the solution, we have to understand the problem. In traditional REST APIs, if server A wants to know if server B has new data, it has to ask over and over, and this is called polling. If you poll every 5 seconds, that's over 17,000 requests a day. And most of these responses will just have no, nothing new. It's a massive waste of resources and it creates a built in delay. There has to be a better way. Enter webhooks, often called a reverse API. A webhook flips the communication model. Instead of you calling an API to request data, you give the platform like Stripe, GitHub, or Shopify a URL endpoint on your server. You say, hey, don't wait for me to ask. Just post to this URL the exact millisecond an event happens. It's highly efficient and genuinely real time. Let's look at a decision matrix. Use REST APIs when your app needs to pull data on demand. Use webhooks when you want two backend servers to talk to each other asynchronously the moment an event occurs. But what if you need real time two way communication between server and a web browser, like a live chat? That's where WebSockets come in. Modern systems will use probably a combination of all three of them. Because a webhook endpoint is just a public URL sitting on the internet, security is non negotiable. If you don't secure it, anyone can send a fake post request to your app and trigger unauthorized actions. The standard here is an HMAC signature verification. The sender hashes the payload with a secret key and sends it in the header. Your server does the exact same math. If the hash match, the payload is authentic. We also use timestamps to prevent relay attacks and idempotency keys to ensure if a webhook is retried, we don't accidentally process the same data twice. Here is what a small implementation would look like in Node using Express. Note, there are three very critical things. First, we use a crypto.create HMAC to verify the signature. Second, we use a timing safe equal to prevent malicious attackers from guessing our secret based on how long this string comparison takes. Finally, we return a 200 OK status immediately before we do any heavy lifting. If you take too long to respond, the provider assumes that the delivery has failed and we keep on retrying and flooding your server. Note, this is just a kind of a pseudocode of how you write something like this. It's nowhere near what production code uses. So, webhooks are amazing for getting two servers to talk. But what if your server needs to talk to a user's smartphone? That's where push notifications come in. They are the modern day digital postal servers. Whether it's an iOS or Android device, push notifications allow you to wake up a user's phone, show an alert, or update a batch, all without user actively running your app. You just can't send a message directly from your server to an iPhone. You have to go through the platform's gatekeeper. For Apple, this is APN, Apple Push Notification Service. And for Google and Android, it's FCM. Think of these as massive global post offices. FCM is actually incredibly powerful because it acts on a cross platform layer. You can send it one payload and it will route it to natively Android or act as a proxy and forward it to APNs for your iOS users. Just remember, you only get 4 kilobytes of payload data, so you have to keep it light. How does APNs know which specific iPhone out of billions to send a message to? It uses a device token. First, the app asks the user for permission. If granted, the device registers with APNs or FCMs and gets a unique token back. The app then sends this token to your backend database. When you want to message that user, your server wraps up the payload, slaps that token on it like mailing address, and hands it to APNs for final delivery. If you have 50 apps on your phone, they aren't all maintaining open connections with 50 different servers. That would sip out your battery really quick. Instead, the operating system maintains exactly one persistent TCP connection to an APN or FCM. It keeps this connection alive using tiny heartbeats, and all the incoming pushes for all of your apps are multiplexed down this single power efficient pipe. The phone stays in a deep sleep state until a push notification arrives over that socket. But what happens if the user's phone is off? The post offices have to hold that mail, but they have different rules for it. Apple's APN coalesces the message. If you send three messages while an iPhone is off, APNs throw away the first two and only deliver the third one to the phone when it turns on. Google's FCM, however, will queue up to 100 messages. For both, if your server gets a 410 error indicating a token is no longer valid, like if they uninstalled your app, you must prune that token from your database, or Apple or Google will rate limit your server for spamming. To wrap it all up, webhooks are for server to server real time updates, push notifications are for server to user alerts, secure webhooks with HMAC signatures, keep your push payloads under 4 kilobytes, and always respect the user's battery and attention by pruning dead tokens and optimizing your triggers. If you implement these correctly, you will have a highly scalable, event driven architecture. Hey, if this video helped you understand this topic, don't forget to like and subscribe. You can also drop your suggestions down in the comments about the improvements and the topics you would like me to cover next. Till then, thanks for watching, and I will see you in the next one. Peace.